Waves, presenting a solution flowchart for SIH 2025. Argo Ocean data is a global treasure, but it is stored in complex NetCDF files. Accessing it requires coding expertise and weeks of training, making it difficult for policymakers, students, and even researchers to use efficiently. Now my teammate Avish will continue the presentation.
Our idea is to build an AI-powered user-friendly dashboard for Argo data. We convert raw net CDF into PostgreSQL for structured queries. Then, using LLMs with retrieval augmented generation, a user can ask questions in plain English, and the system automatically generates SQL queries, plots, and even geospatial maps. The dashboard built with Streamlit offers float trajectories, depth profiles, time series trends, and a chatbot-style interface for natural interaction. Now, Nikhil and Aditya will talk about the innovation and uniqueness of the idea.
So the technical implementation could be broadly classified into two sections. First is how we would pre-process the data, and second is how we would add a layer of LLM or RAG to it. So for the first stage, when we are fetching net CDF format files from the Argo repository, they consist of millions of profiles and multidimensional information consisting of temperature, salinity, pressure, depth, etc. We can process them using Python libraries such as netcdf4 and xarrays, and then we can embed it using a sentence transformer models into vector databases such as SIH or Chroma. Then, to add a level of sophistication, we could add a layer of RAG or LLM, which Nikhil would talk about.
Yeah, so once the data is indexed in the vector database, we build a RAG pipeline. When a user enters a natural language questions, like let's suppose that user asks us what is the average temperature in the Indian Ocean in July. So the system would retrieve the relevant summaries from the vector store and pass them along with the query into the large language model. Let's suppose we are using Mistral or Win. The LLM then generates a context-aware human-readable answer, which is actual Argo data. We also support visual outputs like temperature depth graphs, flow trajectories, which are rendered using Plotly or Streamlit. This entire pipeline's from data to retrieval to intelligent answer generation makes Argo data accessible to non-expert through a simple conversation interface. Now, Yash would talk about feasibility.
Our solution is both technically and economically practical. Argo provides 25 plus years of open access data with 150,000 new profiles each year. Mature tools like Xarray and Pandas can process over 1,000 files per hour. Visualization frameworks like Folium, Plotly, and Streamlit are reliable in geospatial data. Mature tools, LLMs and vector search are already robust and can be fine-tuned for oceanographic terms. Deployment is cost-effective, about 4,300 rupees to 8,000 rupees per month, and performance can reach 85% to 90% accuracy with proper validation. So our pipeline is sustainable and future-ready. Now Anushka will talk about impact and benefits.
Coming to the impact and benefits, most importantly, our solution democratizes access to Argo Ocean data such that users don't need coding skills or weeks of training. For researchers, this means less time cleaning files and more time doing real-time analysis. Policymakers can get quick insight from this Argo that can better guide their decisions in areas such as disaster response, fisheries, and climate planning. For students and educators, it makes real ocean data accessible in classrooms and for research purposes. So overall, by putting this data in clean, simple, and interactive form, we can make the ocean science more impactful, collaborative, and inclusive.